Okay, I want to spend some time today building on some previous topics while moving into some panelization concepts, some basic methods for drawing out panels or skin systems onto these kinds of complex forms. Again, kind of reinforcing some of the stuff we've done earlier, putting that into context when it comes to modeling a skin, and then kind of walking through a couple of basic ways of using Grasshopper, which will automate a couple of tasks for us here to save some time and make things a little more accurate. So we're going to walk through a variety of topics using this as a base file. This is also based on some office hours I had with one of the groups in the studio. Okay, so you can see we've got this base surface form, and if you look at the isocurves and the white lines, you'll notice that they're not very conducive to the structural sections, just because they're not perpendicular to the form. And this is while it is a clean surface, this is not an uncommon thing. So what I did is instead I designed just a basic set of construction lines that are built from the outer form that I was looking to achieve here. I drew these out radially from that radius, and then just straight on from this line segment here that's straight. I use these lines to direct a set of sections using the section command in the top view through the form, and to draw out these red lines. So that's covered in an earlier video tutorial, so I'm not going to show that here, assuming that everyone is up to speed on that. So we just kind of move that over because we don't really necessarily need this base surface anymore. We're going to kind of reconstruct our building through these sections here. But because we started with a surface that was pretty clean and modeled continuously, what we should expect is that all the seams of these curves line up. And I'm going to type in the direction command after selecting some of those sections just to take a look. And you can see that the direction command is going to show us the direction of the curve, which will be important for lofting, and also the location of the seam. And you can see this one here is an interesting one, where this one looked like it's been flipped around for some reason. And we'll get to that in just a second. But what's important, I think, just is to just know that because these weren't drawn independently, one at a time, by dragging control point curves, it's very likely then, because of that, the seam where this curve begins and ends will be more or less in the same position. And that's important when it comes to the next step, which is to divide these curves into a set of points. And in this first step, what I'll do is kind of draw out a new wireframe using this method. And this is a wireframe that can be used to start building, let's say, rectilinear panels into these sections. So what I'll do is I'll select all of these sections here, and I'll just divide them. And you can see that our seams align pretty nicely, which will give us a good effect in the end, which means our points will align more or less pretty well. So I'm going to just type in 25 here, and go ahead and click enter. So now I've drawn a set of 25 points, or 26 points, 25 segments, 26 points along each one of the curves. And you can see that because the seams were aligned, the points, where they start the division process is going to be more or less in the same position. And because these curves are kind of well, they're self-similar. They basically sort of scale as they go down. It stands to reason that if we connected these dots, we would end up with pretty smooth curves along the length. I'm going to select those points, and just I'm going to pop these on a different layer just to darken them a bit, so that when I draw my polylines in the next step, you can see them a little better. So I'll just start drawing these polylines out just as a way to talk about that nice division of, because I know this was an issue with some of the models where division points weren't aligning, and that's mostly probably because the curves themselves were not derived from a single object like the surface. And so now as I draw these lines across as straight line segments, I'll be building a new wireframe that didn't exist in the surface. And I'll be building it in a way that will allow panels to align if we want them to, at least along that direction, and also, of course, in the short direction. So I'm kind of rebuilding the wireframe here manually to get it to do what I want, and that came from modeling the sections in a way that was constructed at angles that were drawn from the outer profile of the form. Okay, so once again, the relationship between form and the structural system, I think needs to be direct, especially with shapes like these that are pretty complex and hard to model when it comes to building components. So I'm just going to do one more just for good measure here. I'll give you some time to play around with this. There we go. Yeah. Now the next thing is to, if we're going to put panels into this, we're going to start skinning this. One thing we should be aware of is that if we draw out a straight line from this point to that point, it's going to be on the inside of our curve, and that could be an issue, especially when it comes to adding material thicknesses. Now, if you're going to redraw the section after the panels are drawn, that might not be a problem. For example, if the section has to be redrawn through a section of the panels themselves so that they're shaped, to attach directly to the panel, then you would do that first. But if you want this curvature, if you're kind of bending this part into position and then attaching a cladding to it, what we need to do then is offset these curves a little bit to float these panels off and then develop a connection between the sections and the panels. So I'll cover that because it's, I suppose I can cover both. But anyway, let me make a copy of this and just drop it down here so we can keep track of everything as we go. And then what I'll do is just type in select point, and I'm just going to hold control and remove those from the selection. Remove these from the selection, and I'll just delete these. I don't need these points. I want to start differently here. And then I can get rid of these curves for now to start a new example. I'm going to go to my cyan layer, and similar to what we did with crystal bridges, I'm just going to offset these curves to give a little bit of space in between the curve and where the panel might reside. And I don't know exactly what the right spacing is. You can discuss that, with your faculty as you move forward in terms of what the proper connection of a cladding to the frame actually is. But this is just an example for how you might model that offset. So I'm just going to offset the curve. I don't know how this is going to translate. Okay, so the distance I'll use in this model is something small, like 0.12. Let's see how that looks. Yeah, I'm going to do a distance of 0.15 and just go ahead and click. Now remember, I didn't model this to scale, so I apologize for the strange units there. It's not modeled to any sort of particular scale. It's just a sample form with an arbitrary scale. But anyway, I'm going to go through and offset all these curves. Clicking on the outside of the curve as I go. And as I'm clicking here, I'm starting to realize that the red lines, most of them, because they were cut from the surface, are not going to be, and the way that Rhino does this is that it's going to be as accurate as it can follow that surface. So sometimes these control points can be a little unevenly spaced, and that may or may not be an issue later when we do some lofting. So what I'm going to do right now is just rebuild these. So I'm going to select that layer. You can just type in select layer. You can select the cyan layer. Go ahead and deselect anything that's not, what we just drew. And I'm just going to type in rebuild. And here we got to be a bit careful. We're going to need a lot of points to do this. And if we zoom in, you can see that there's some discrepancy between our original curve and the new one. A better way to do this would have been to rebuild the red ones and then offset those. But it's okay. We can just be a little more specific here. So let's just increase the point count to something like 50. And that's going to change our maximum deviation to something that's extremely small. and that's well within the tolerances of any kind of architectural system. I mean, that's a thousandth of an inch. So our deviation here is very, very, very minimal with that many points. We can delete the input and click OK. So now what we've done is we've redrawn those offsets with a much more evenly distributed set of control points, which may affect and probably will affect the surface that these create. So before I go any further, I'm just going to make a copy of this as well, and I'll save it for the next step. So I'm just going to hold Alt and drag that over like that. But while we're still on the topic of, drawing out a new wireframe, let's work with these offsets now and do something similar. So we can just do a division of all of these. So I'll select these manually here because there's not that many. Go ahead and divide in the same way that we did before. We don't have to drag seams around. That looks fine. And off we are. So we have a new set of points now. I'll change my layer and select the last thing that was created there. I'm just going to drop that onto the default layer. I keep forgetting to switch. And then I'll just draw my polylines over as a way to get started. And you may or may not need these polylines. It sort of depends on the drawing you want to make, or whether or not you need these as for center lines for mullions or other kinds of secondary or tertiary framing elements. That's there for you as an option. And also the spacing between these points obviously is determined by the density of the point pattern that just came out of the division command. So you can increase the number of divisions and get a tighter spacing. All right, so I'm just going to kind of go partially there. So there's some new lines that can be drawn as a new wireframe, and you can complete it out, and off you go. In part 2 of this, I'll talk about a way to do this in Grasshopper that'll save you quite a bit of time, especially if you have a more complex setup than this. But to add panels, what you would do is just start connecting the dots. And so we can go to Surface, Corner Points, and just start clicking at the 4 corners to begin the process of basically skinning this wireframe as we've now drawn it. And these panels will appear to be partially planar. Well, they're going to appear to be planar, but actually they're not. Most of these panels are going to be subtly twisted. You can kind of see that there. And that's just because the 4 points in space are not residing along the same plane. And that's something that is very hard to do in Rhinos alone. So what we'll do is, in a later stage, we'll use Grasshopper to fix this issue if this is a problem for you. For example, if these are glass panels or if these are panels that cannot bend in any way, then you're going to want to fix that. But if this is modeled like from metal panels or a surface that needs to be kind of smooth along the length of the sections, a little bit of twist is probably doable, especially with thin sheet metal or even thin wood, as you know from building the boats. So it really depends on the kind of material that you're working with. Okay, and again, you can keep going here and continue it on. If you're really concerned about the twisting and you don't want to, let's say, reorient these panels in space so that there's no gaps, one thing you can do also is just triangulate the panel along one of the long edges, and that will always produce a planar panel because a triangle is always planar. But what this does obviously is add a kind of a fold in between. And maybe a better example of that would be to show it on one of these twisted panels down here. For example, this one, let's just remodel these as triangles, and you'll see that there's a bit of a fold there. Yeah. And now everything is nice and flat, but of course we have another seam that we've got to deal with, which may or may not be desirable depending on the project. This is also an interesting thing that we're playing out here. I mean, you can imagine a set of panels that are diagonally cut across the surface diagonally in 2 directions, forming a kind of triangulated diagrid, if you will, while other panels are left planar. So you can really experiment with, the types of panels you're putting in between the sections, just all starting with the very simple logic of 4 points that determine basically the corner points of each panel. You can also add depth to these. So there's no reason why you couldn't, add shape to these panels just between the 4 corner points. So imagine they pop up a little bit, they fold upward, or maybe they have a bubble to it, maybe a curvature, something like that. It's totally up to you, and really all we're doing is setting up the framework for that to take place. You can model more or less anything between 4 corner points and still get it to fit, so long as you know that it's within the realm of, you know, the material capacity that you're dealing with. Okay, so there's just a little bit there in terms of wireframing. And let's keep going while we're in Rhino to explore a few more topics. So I'm going to kind of come over to this one here where we left off before. And actually, we talked a little bit already about the importance of rebuilding, matching up seams. I'm going to do that one more time, demonstrate that one more time actually by just, I'm going to start over. I'll take these and since we already used them, I'll just delete these. In fact, I want to try a different process. So just, yeah, we can just start from this here instead. And what I'm going to do now is actually, instead of offsetting the curve in that direction, I'm going to offset it inward to give, to set up a framework that assumes that these sections have some material thickness, of course, because they will. So what I'm going to do instead is just extrude this curve. And I'm going to click both sides up top. The direction should be set to being perpendicular to the curve itself. And then I'll just choose a small dimension for that, like what we did before, like something like that. Yeah, maybe something like that. So 0.12 in this model. And I'm going to go through and just do that for each curve. And because the Rhino will save the previous inputs, you can just hit enter a few times, running the command again and then running the input one more time. And you can see that because it's a closed curve, Rhino's able to determine the perpendicular direction nicely. So these are all, they're all straight sections, but they're oriented in space in the same direction as the curve itself, and I don't have to set that manually, which is really nice. Okay. So this, we're going to use this as a way to just determine an offset between the sections. And that offset could be filled later with, you know, the thickness of the structural rib. I'm going to go to my blue layer here and just type in duplicate edge, so dupe edge, D-U-P edge, and I'm just going to duplicate all those edges on those surfaces there. And I like the dupe edge command more than silhouette or something because it forms continuous lines along the entire edge. Silhouette, we'd have to go back and clean it up a little bit. There'd be lines in there that we didn't want, and it may form broken curves. Okay, nice. And I'm going to make a copy of this over here. And then I'm going to select the surfaces, deselect all these surfaces because we want to keep them, but you can delete those from the next stage here because I don't really need them anymore. I just used them as construction surfaces. Okay, so this is going to be a case for where we're going to want to experiment a bit with some rebuilding potentially and see how the lofts come out, maybe even some seam adjustments. So let me just see how a loft works between these two things here. I'm going to start, I'm going to try a different process of skinning here and walk you through another method for developing the panels using instead ribbons. And I'm going to see how this comes out first, how the loft, okay, so this is pretty clean. And we're not simplifying this one, so let's take a look. It's a good surface and it's actually, you know, pretty clean. But if we wanted our wireframe to be super clean, something that's a little more evenly distributed, without these double lines here. And also, if we, actually I'm going to do one more. I'm going to loft the next set as well in between, like this. This one will show us a little bit of a problem, right? So here's, this is one of the curves is in the wrong direction, so we can cancel that. Click one of the curves and hit flip. Let's change the direction of one of them to see if that solves it. And let's try to rerun the loft command. And it looks like it solves that issue. And if I click on that curve and that curve just to show the control points, let me get a good view that you can see here. There we go. you can see that this point here is being translated across, and that point there is being translated across. And that's why we're getting two isocurves. But if we wanted to make sure that there's only one isocurve in between those points, we could try that as well. And one of the ways that we can do that is going to be to rebuild these curves, or even actually we don't necessarily have to do that. We can just rebuild the surface that we draw through it using the same number of control points that this line has. So what I'm going to do is I'm going to select all of these guys here. I'm going to run through this in a really kind of precise way, maybe overkill, but just to demonstrate the point. So I'm going to go ahead and click on these guys. Actually, I'll make that faster by just locking down these layers here. All right, and just, there we go. Oops. Yeah. All right, let's do it that way. Okay, let's lock all that down. Okay, so now we've just got those sections. Let's type in rebuild, and yeah, I want to rebuild these with 50 control points each. I'm going to preview that to see what kind of, and we're seeing very, very tiny little bit of deviation here, nothing to even worry about, so I'm just going to go ahead and click OK. Now it looks like my points are nicely distributed like we saw earlier. Very good. Now that doesn't mean that our surface is going to be solved, so let's take a look at the loft in between them. See what that looks like. Pretty nice, but also, yeah, again, we have a lot of lines in between. And if we're going to use this as a wireframe to develop a drawing or something, this will come with a good start, but still a considerable amount of cleanup if you wanted to extract this wireframe and draw it out, because you got all these double lines here. So let's see what happens if we instead run the loft command in between these two lines again. And in our options here, I'm going to go with straight sections, which we should have done earlier. And then I'm going to click rebuild with 50 control points. And that's the same number of control points that we have in the curves themselves. That's not necessarily important. I mean, you can increase this a little bit and still get a nice effect. But just because we rebuilt the curves with 50, I'm more confident that the surface that's going to result from this will very much match the original curve. Okay, because rebuilding sometimes could cause some deviation. In this case, it should be very, very, very subtle, if not probably impossible to see. So I'm going to click OK. And now what we've done is we've developed a pretty clean wireframe that you can either extract to develop a set of panels, so you can start drawing across, and these could be individual panels if you like. You can use these lines as score lines onto a ribbon of paper, which, by the way, this surface should be able to unroll. I think many of you are familiar with the Unroll Surface command, and once we unroll that, we do have a bit of deviation there, so that's something to pay attention to. It is a little bit bigger after unrolling, and that's just due to the geometry. So some of these will unroll a little bit more accurately than others, but this is another way of building a model by just kind of paper strips that you kind of lay into the sections. Anyway, we can talk about fabrication a little bit later on in the semester, if that's going to be something that's cause for concern for many of your work. I'm going to loft a couple more of these to see how they're coming out. Pretty good. Yep, seams look like they're aligning really well. The panels look like they're aligning really well, and it's starting to kind of, in a way, bias the shift in the isocurves a little bit. And you can kind of see that happening here, which, actually, because we're modeling them separately, in my mind, architecturally speaking, I don't think these panels necessarily have to line up past the sections if the section is what you're going to show. And actually, something like this sort of offset paneling, could actually be quite nice. But if you did want them to align, then of course this method would be preferred, okay? Because you have more control over exactly where the edges are. I'm going to start from this end as well to take a look at how these are coming out. So far, so good. And now, this one we might be able to adjust. I want to start pointing your attention toward whether or not we think the panels are starting to transition nicely, or if they're really starting to deviate from one another too much. And so far, I think these are looking pretty decent. But here we're starting to run into a little bit of an issue, right? You can almost start seeing a kind of twist that's starting to occur with these sections. And as a wire, as a set of panels now, I think there is a limit on how this is going to look and whether or not this even makes sense. You're going to get a lot of twist out of that panel. In fact, in this case, you're probably going to need to triangulate that piece, right? So if this is going to be your method, you want to pay attention to these isocurves if they're going to be the edge seams, because this is going to create a situation where you're either folding this one or orientating in space quite a bit so there's a gap, or twisting it so much that you need a particular material to do that. So let's look at a way where we might be able to fix this and control where those isocurves go. So let's type in CRV seam, so curve seam. And I'm going to just select this curve here. It's going to show me where the seam currently is, and I can adjust that. So I'm going to adjust this to around here to see if I can, and hit enter to see if this fixes the loft. I'm going to loft those two curves again, thereby moving the seam across, because the first curve that I select is going to bias the other in terms of where the seam goes. And now when I click the loft command, you can see now that I've adjusted this to the point where I get much less twist in that panel that I just showed earlier. And if I do it again, I can probably get this to be even a little bit better. So let's try this one more time. Curve seam. It's going to show us where it is. I can drag it up a little bit, maybe in that direction, to see if that fixes it. Hit enter, loft. And that looks like it's even cleaner. So now I have minimal amounts of, I have less twisting, and it's the same amount of cupping, and that's going to be the case because it's curved, but I have very little twisting now, right? So this is a more efficient way of modeling these pieces. And I'm also getting an overall pattern that appears to transition better. And if you're careful with this process, you can probably align the seams even better than what I'm doing to try to get these lines to match up across the ribbons even more carefully. Because, from an aesthetic point of view, looking at these seams from the outside, especially on this elevation, maybe that's not so perfect, it's not so great. So adjusting the seams a little bit could help with that. Okay. I'm going to do that again. Curve seam. I'm going to bring this seam over in a similar place. Hit enter. Let's check out how the loft goes. Pretty nice. Now these two pieces have a pretty nice relationship to one another, even though they don't align perfectly. But this one, you know what I mean? Because I'm looking at this parallel, whether or not these are kind of mostly parallel. And in here, suddenly they start to dip down a little bit on that end. So we can probably fix that one as well with a better seam adjustment. Okay, so this is, once again showing how just using a couple of understanding the nature of the curve, the quality of the curve, where it came from, and how it's broken down in control points, and also where the seam is, will affect the quality of the surface, and therefore may also influence the panelization. Okay, so you can use these surfaces as as a cladding method. Another thing that we could do is also just use these as input surfaces into Grasshopper to develop a different way of modeling the planar, let's say the planar panels. All right, so I'm going to make a copy of this, bring that over here, and while we're on the topic of that, we'll use this as an example, and I'm just going to for this step, just to demonstrate it, I'm going to delete some of these out. Just use 2 of them for now. I will use these as input surfaces. The other thing that I want to do to set us up for the Grasshopper work, and this may be a good point after this step to break and get into part 2, is to just take along with us these curves here. And I'll input these also into Grasshopper to develop that wireframe let's say more quickly and pretty accurately without having to do it manually. So I'm just going to copy these over as well. And this is a new set of work this is a new set of curves that I can work with when we get into the next step, which is to play with Grasshopper for this. Okay, so we'll see you in part 2.